Welcome everybody to CCCS 111 Introduction to Programming in C. In today's lecture, we're going to jump ahead a little bit to chapter 6 because we want to cover this topic called arrays. So we're going to skip the content for the time being, just for today's lecture. And the reason is that basic knowledge of arrays actually comes in very handy when you are looking at loops. So we will just briefly touch this chapter and then come back to it um, after we have covered the topics that we're skipping for today. So let's jump right in. So this chapter basically serves as an introduction to data structures because arrays are what is known as data structures or some of the most basic data structures uh, in C. Now, what are data structures? Data structures, you could for now think of them as uh, a special organization of data, and arrays are the simplest type of organization that you will see in this course. And then in chapter 10, we will look at the notion of struct or the structure data type, uh, which is a bit more advanced, but we'll talk about it when we get there to chapter 10. Now, arrays are and structures are basically what are known as static entities, which means that they remain the same size throughout the program execution. So what that means is once you've defined arrays and structures, their size cannot change. So initially, once you define an array and you assign it a size, and similarly for a structure, then their size remains the same throughout the program and you cannot change it. Now, what are arrays? Arrays basically are a group of contiguous memory locations that are all of the same type. Now, I could give you a very simple analogy to this. You could think of this as maybe a rack on a shelf in a library. So, if you go to a library, what you generally have are bookshelves, right? And on each bookshelf you will have something like a rack, and then on each rack you will have books that are placed next to each other. So these are kind of contiguous locations, so they're placed one after the other or touching each other, kind of. So, and normally what you would see in a library is that on the same rack you generally tend to have books that are of similar themes or similar topics stacked together. So one rack might have science fiction books, all of them together, and then another rack might have uh, mathematics books or something else. So that's what arrays are also like. So arrays are contiguous memory locations and they're all of the same type. So let's look at a very brief example, which is shown on the next slide in figure 6.1, where what we have is um, an integer array because this stores integer values, right? Minus 45, 6, 0, 72, 15, 43, no decimal values. So this is an integer array of size 12. And so it's kind of like a book rack where you could think of this as 12 books all from maybe science fiction, or 12 novels on the same shelf sitting next to each other. So here you have 12 uh, integer values all stored in 12 contiguous memory locations. Now, if you look at this array, it actually has 12 elements. And if you actually want to address one of these locations, or you want to refer to one of these uh, integers stored inside an array, so if you want to refer to the position of a particular element, you need to use the name of the array. So the name of the array is C, and then the square brackets basically mean that you're talking about an array, and then within the array, within the square brackets, you can specify a number uh, to refer to any given particular element of an array. So if we want to access the first element of an array, we can write this as C square brackets 0. Now notice that the index value starts from 0. So the first value of an array generally is referred to using index number 0. So this is the first value, and then because we're starting with 0, the final element, even though the size of the array is 12, the final element, its index number is 12 minus 1, which is 11. Okay. And so the first element in an array is generally referred to as the zeroth element, right? And array names, like identifiers, can only contain letters, digits, and underscores, and cannot begin with a digit. So remember this. This is another important concept. So all rules for identifiers that you generally see with other variables also apply to arrays as well. And then the position number within square brackets is generally referred to as an index or subscript. Um, the more commonly used terminology is actually index, but you can call it subscript as well. So index number 1 basically means that we are referring to the second element of the array index. So C0, so with index number 0, refers to the zeroth element of the array. Okay. Now, another thing that you want to remember is that an index must be an integer, because memory locations cannot be decimal points. You can have memory location 1, you can have memory location 2, you can have memory location 3, but you cannot have memory location like 3.5 or 3.75. That doesn't make sense. So index numbers that go inside the square brackets have to be integers, or there must be integer expression. So something that gives you an integer once you evaluate it. So let's look at an example. For example, if we have an integer 5 and an integer 6, then this expression C is a plus b plus equal to basically first of all refers to, so first let's look at the left hand side. So this is a plus b, which is 5 plus 6, which means that this is C11. So that means that you're looking at the 11th index number of the array C, and what you're doing is you're increasing its value by 2. So this plus equal to means that you're taking what is index 11 and you're adding 2 to its existing value. But the thing that you want to notice here is that, here you have something which is an integer expression. So once this expression, so a plus b basically is an integer expression, and it evaluates to an integer value, which in this case is 11. So for the index, you either need to have an integer value or an expression that evaluates to an integer value, not a floating point or a hexa or a decimal value or something. Floating point or a decimal value or something like that. So let's look at the array, see a bit more closely. Actually, we have already talked about this. It has 12 elements which are referred to it using the index numbers inside square brackets. C0 is the 0th element, C11 is the last element, and then you can see C0 contains a value of 45. C1 contains a value of 6, which you can quickly verify. C0 is minus 45, sorry, not 45, it's minus 45. I read that wrong in the previous slide. C1 is 6, C2 is 0, and then C11, if you look at it, is 78. So you have the name of the array, you have the size of the array, you have the index number of the array, and then you have the values that are contained inside the different locations inside an array. Here's another command which basically takes adds up the first three values of the array C and then just prints them. So this adds C0, C1, C2, the first three elements, adds up their values and then prints it. Similarly, if you want to divide the value of element 7 of array C by 2 and assign the result to a variable x, you can do so by writing something like C7 divided by 2, assuming that the variable x has already been defined. Um, one last thing that I want to mention is the brackets that enclose the index of an array are actually considered to be uh, an operator in C, and so if they're considered an operator, that means that they have to be assigned some level of precedence, because if you see an expression which contains arrays, um, then you need to define or give the brackets some precedence, because they will be used in determining how the expression is evaluated. And now, since these parentheses, since these are brackets, they are going to be evaluated first. So they are given the highest priority, just like your normal parentheses. So this table basically in the precedence shows the precedence, and you can see the square brackets and the parentheses or the round brackets have equal precedence, and then these are followed by additions, subtraction, and multiplications, etc. So whenever you see an expression which contains maybe an array 1 plus a plus x times 3, then equal to y maybe, then what will happen in this expression is whenever the compiler sees this expression, this is the first thing that it will evaluate. So it will first evaluate, okay, what index of this array do I need to access? And of course, arrays occupy space in memory. And if you want to define an array, you first also need to define the type of the array. So you have to first of all define the type of data that this array is going to store. Now the array C will store integer type of data. And then of course you also have to give the name of the array. Then you have to follow those by square brackets. And then within the square brackets, you have to specify the size of the array, which in this case is 12. So what that means is that C is an integer array of size 12. Similarly, you have an array which is B. Over here that is being defined. And what is B? Well, B is an integer array uh, consisting of 100 integer elements. Um, the zeroth element, could call it the first element as well of the array. So zeroth element is B0, followed by B1, followed by B2, up until B99. Similarly, X is an integer array of size 27, which will be which will consist of these elements. So the first or the zeroth element is x0, second one is x1, and then the last one is x26. um, and that's pretty much it. So thank you.